In this video, we are going to understand how API hook works. So now let us consider the case where we try to delete a file on Windows. So what happens when we try to delete a file? So when you try to delete a file on Windows, the process which is responsible for deleting the file is Windows Explorer. Now internally assume that Windows Explorer calls an API delete file, which is implemented in kernel 32. And when Explorer tries to delete a file, the main module in Explorer calls the delete file whose code is implemented in kernel32.dll. Now, with the help of API hooking, the functionality of delete file can be modified in the running process explorer.exe in such a manner that it does not change anything in the explorer.exe binary. Now this functionality can be altered in such a way that it would not delete certain malicious file, and this can be done with the help of API hooking. So let us look into some more details. So assume that this is a process explorer.exe, which deletes the file by calling the delete file API code, which is implemented in kernel32.dll. Now, here comes a malicious process. And basically what this malicious process does is it injects a DLL into the explorer.exe process. And this injected DLL has two components. One is the code patcher, and there is a fake version of delete file. And this code patcher, basically it patches the code in such a manner that the call to delete file in the main module, instead of calling this delete file in kernel32.dll, it is going to call this fake delete file, which is implemented in the injected DLL. And at some point of time, this original delete file is called. It may be called before this fake delete file or after this fake delete file. Now, how does this hook works? Now, this is our explorer.exe main module, inside which the call to delete file is there. And basically, the malicious DLL is injected within the virtual memory of explorer.exe. And here is the original delete file, which is inside the kernel32.dll. And basically, if you look into the code of this fake delete file, so here is what is implemented. Say suppose there is a malicious file mal.exe. So whenever explorer.exe calls mal.exe, this code is going to do not going to do anything. But in case the instead of mal.exe, some other file is tried to be deleted, then the original delete file is called. So basically what happens is when explorer.exe calls a delete file, say suppose xyz.exe, then call delete file xyz.exe is called. And after that, this particular code is called, which calls the original delete file, and the xyz.exe is deleted. And after that, the code returns here. Now, say suppose somebody tries to delete the file mal.exe. Now, again, what happens here? There would be a call to delete file with the parameter mal.exe. Now, when this is called, this code would be redirected to this point where there is a check for whether the file name is mal.exe or not. So now here is mal.exe. So basically nothing happens and the code simply returns here. So basically what happens is whenever you try to delete a file whose name is mal.exe, explorer.exe is not going to delete the mal.exe. But whenever you delete any other file like xyz.exe, it is going to delete the file. So this is how API hook works. Now there are API hooking libraries which facilitate implementing API hooks. So the popular ones are MS Detours from Microsoft, Easy Hook, and mhook. So let us talk about malicious use of API hooks. So API hooks can be used to implement rootkits, which can be used to hide malicious artifacts on a system. So basically, if a malware wants to hide a process from task manager, it is going to hook into task manager process. And if it wants to hide a particular file, then it is going to hook into explorer.exe. Another implementation can be web inject, which can be used for man in the browser attacks in malwares. And basically this is used by banking Trojan to basically steal the banking credential and manipulate the banking transaction. So if you want to learn analyzing the hooks, you can join my training at Intel Root Academy. Now, hooks can also be used in security products, and it is there since a very long time. Antiviruses often use API hooks. Apart from that, these days, EDRs also use API hooks. So EDR sandboxes, antiviruses, all use API hooks to log API calls. And by correlating the API calls, the malicious behavior is identified. So if you want to learn internals of how EDR and antivirus detect malwares, you can again join my training. Here is some more details about my training, Malware Reverse Engineering Beginner to Advanced, the on-demand version. And it incorporates basic malware analysis, reverse engineering, detection engineering, and malware development. If you want to register for this training, you can scan this QR code.